Welcome back to data journalism. Not as we expected it to be, but here we are. So we're just going to figure this out and get through it. I'm going to be dividing up these online video lecture thingies into three parts. It's going to be what, why, and how. So the what today is going to be geographic data. We're going to start looking at data sets that are created to be maps, to be geographically located, that will give you some sense of distance between things or where they're located on the planet. It's using the plane of the map as the query layer. So we're going to look at maps as data. We'll use distance and spatial patterns to identify issues and ideas and where things are and where they aren't and things like that. There is the why we're doing this. There's truly an epic amount of geographic data out there, and truth be told, there's so much of it out there that it's not all very well explored by journalists in particular. There are whole industries of people who do work with this stuff every day, and there are whole disciplines on this campus that are all about this. We're just going to dip our toes in. If this is something that interests you, this is something that you can study for a very, very long time. So the reason that we're interested in it is because spatial patterns can be really revealing. Sometimes the spatial pattern is the thing, and what we see is what is there, and that's what's the interesting thing. Sometimes it's what is not there that is the interesting thing. It's looking at the absence of a thing on a map that is fun and exciting. So we're going to use a new library called SF, and to show that to you, I'm going to switch over to a screencast and we'll deal with the how. So here we are with the how of using geographic data in R. So I've just got a notebook opened up here. I haven't done anything really special to it, but the first thing we need to do is we need to get the SF library on your computers, and I'll be honest with you, this is the first time that I'm using this in a class, so I'm a little bit interested to see how this goes. But you're just going to go over to the console, do install packages, SF. It is going to load a number of dependencies which are going to need to install. Not all of them install cleanly, I won't lie. So try to run this first before you do anything else. You really ought to do this early in the assignment week because I need to get you help. So if you run into problems with this, reach out on Slack as soon as possible. So you'll run it. I've already got it installed, so I'm not going to run it. But we're going to load up three libraries. The tidyverse, which we almost always do. We're going to load SF, and we're going to load janitor. And I'll show you why about janitor here in a minute. So the first thing that we have to get into our heads about geographic data is that it's very, very different from what we're used to. What we're used to is pretty much a single table or maybe a couple of related tables that we're going to join together at some point. Geographic data by itself is not a single file. It's more like this, where there are layers to the data, and you'll get multiple layers to create a map, or what you would consider a map. So in this example here, there is street data, there's building data, there's vegetation data, and when you add them together, it becomes integrated, it becomes the map. So what we are trying to do is figure out which layers we need, what layers we're querying against, which layers are data, which is versus just sort of display and things like that, and we'll get into that in a little bit. But first we have to think of data as layers. The second thing that we need to think about is when we get data from a place, geographic data is never just one file. It's always going to be multiple files. So in the book for this chapter, there's a link that will take you to the data that we're going to work with, which is this hospitals data, which comes from the Department of Homeland Security. But this is what hospital data looks like. This is what geographic data looks like. It is 6 different files. Some of them can be even more than that, but the most important ones that we get here are this shape file, which is the main file that we will be doing most of the work with. This PRJ file, which is the map projection. The book talks a little bit more about map projection, so I won't go into it here. And this DBF, which is the database file underneath the shape file. And these other ones are just sort of pieces and parts that sort of glue the whole thing together. So when you go get your map data and you see all of these files, they are all important. They are all part of the geographic file and will all get read in multiple different ways. So the shape file, in a sense, is just the pieces that glue it all together here. So make sure that you have all of these files. If you ever get a geographic file that doesn't have a projection file with it, woe be unto you, because it means this unprojected file, and that's going to be bad. If you have some of these other pieces like the shape or the database file missing, it's just not even going to work. So when you get data, it'll come in a zip file like this. You'll unzip it. It will unzip it into a folder like this, and inside the folder there should be 6 files, and that's normal. That's what it looks like. So similar to other things that we have done, we're going to read it in, but in this case we're going to use st_read instead of read_csv, which we're used to, but the format's the same. We just create a thing called hospitals. We're going to read that data in. We're going to path to it wherever you put it on your computer. Just point to that. And when you run it, you're going to get this, which is, again, pretty similar to what we've been used to with read CSV. But here is reading layer hospitals from this data source using the driver ESRI shapefile. The book goes into what an ESRI shapefile is, so check that out. This is a simple features collection with 7,581 features in 32 fields. So in other words, this has 5,081 features in it, and there's 32 fields of data that get applied to it. The geometry type, this is also important to note, it's a point map. So there's a dot for every hospital that's in here. The dimension is the X and Y, that's just the sort of the coordinate points. There's a bounding box that just sort of tells you where on the globe these things are. And here's what the projection is. So it's using a projection called WGS84, which, without knowing it, you're extremely familiar with WGS84 because you've used Google Maps, and that's the same projection that Google Maps uses. So WGS84 gets used a lot. It's a fairly common projection. So not necessarily surprising that we're seeing it that way. So if you just want to see what you've got, you can use ggplot. So we just go ggplot. We're going to add a geom sf for simple features, and we'll just tell it what our data is. And when we run that, here you go. Here's every hospital in the United States. So we made a map. Hooray, we're done, right? Yeah, not really. What's interesting to me is to see, Guam and Federated Micronesia, and you got Hawaii out here and Puerto Rico here. You can see sort of the basic shape of Alaska. Like, this is a pretty, we're a pretty spread out country when you look at it this way. The other thing is, this just looks like somebody spilled a bunch of dots in a pile, so it's not particularly useful. Well, good news, we can use filtering the way that we are accustomed to. So let's go ahead and create a file called any, or maybe any hospitals, because that'll be more useful later. And we'll use our hospitals data, and we're going to filter. And there's a state field in here, and we're going to filter so state equals NE. And we run that over here in my environment. My Nebraska hospitals has 111 hospitals. So there's 7,581 hospitals in the United States plus the protectorates. There's 111 in Nebraska. Well, we don't really know this data, and we don't really know what is in there. So it helps to have Janitor installed so we can run table on things. So let's do any hospitals, table. And I'm going to run this against a field called type, which we can look at this over here and explore it. Here are all of the fields that we've got. So name, we've got address, city, state, zip +4 if we really want to send a really efficient letter to them, I guess. Telephone number, the type of hospital, which is going to be important because you can see right away, children's hospital, chronic disease center, things like that. Not all of them are going to be hospitals in the traditional sense of what we would think of as a hospital, sort of a general acute care facility. Status, whether closed or open. The population, not certain what that is, but there is something down here that will be interesting to us that's beds. the total number of beds in the hospital. Now note right away, there's this negative 999 here. Well, how many hospitals do you know that have negative 999 beds in them? We'll come back to that in a minute, but worth noting and worth showing why just sort of pulling this up here in the environment's a good idea. So let's look at this table of types. And these are just Nebraska hospitals. So in Nebraska, there are 3 children's hospitals. There are no chronic disease hospitals. There's 67 critical access facilities, 26 general acute care facilities, 3 long-term, 2 military, 5 psychiatric, 2 rehab, 2 special, and 1 women's hospital. So we are living under quarantine right now, or social distancing, or whatever you want to call it. We're not supposed to be anywhere near each other right now. And so our response to coronavirus is the really big thing on everybody's mind right now. So a decent question to ask is, how many hospital beds does the state of Nebraska have? And we're not even going to try to separate them from ICU beds, from general beds. Like, just literally how many beds can we put people into if this corona gets really, 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 really bad? Well, let's create a new block, and we're going to do any hospitals. And the thing that we're going to look at is whether or not let's just narrow them down to just what we would expect to be a hospital. So we're going to get rid of children's hospitals, military hospitals, long-term care facilities, things like that. The 2 that we're going to look at are the 2 largest categories. So let's do type equals critical access. And then we'll use the pipe character here. Now, somebody asked me this the other day. So this is the pipe, and this is the pipe. What's the difference? Well, this is just sort of known as a pipe. It's just the name that it's been given because we're piping commands together. This is the actual pipe character. This one means, and now do this. So we're going to take Nebraska hospitals, and now we're going to filter them. This pipe means or. So I want all of the type equals critical access, or type equals general acute, help if I can spell, care. So when I do that, I now have 93 features, and I can see what they are. I probably ought to, just to cover my bases, filter out any does not equal closed. Let's see if that changes anything. Nope, there are 3 of them. 3 of them in there that were closed, so that's not good. Okay, well, now we have all of the open hospitals that are in Nebraska. Let's go ahead and we'll call this any open hospitals. I just spelled it correctly, all right. And now, let's take a look at where these hospitals are. So we'll do ggplot, and we're going to add geom sf data equals any open hospitals. There we go. We'll run that. And there is what we get, which, if you're a geography nerd in the state of Nebraska, you can kind of get the sense of what the shape of the state is. So you've got, here's the northern border, there's the Missouri River somewhere along in here. You can kind of tell that's Omaha and that's Lincoln. The Kansas line must be down here. Here's the panhandle because there's nothing out there. So not great, not an awesome look at things. So let's talk about layering now. So let's go ahead and layer in some new data. In the book, there is a link to get some census data, a census geography file. As you might imagine, the census is extremely geographic, and so there's lots of geographic data around there. So we'll create any counties. We'll st read that, and I'm going to just path directly to it in my computer. Yours will obviously look different. Data, and there we go. And you always want to find the shapefile. Unfortunately, the census has some pretty wicked naming conventions for their files, so you're definitely going to want to use tab complete to find this and make this work. So now I have Nebraska counties. Actually, I have every county, which, oops, I should do this and have every county because my file has 3,233 features, which is all of the counties. Note the geography is multi-polygon. So I too have to filter this out. So let's go ahead and look here. State FP will do just fine. So remember from earlier in the semester when we were talking about fatal accident data and FIPS codes, we'll have filter state FP equals, anybody remember what Nebraska's is? It's 31. So when I do that, Nebraska counties now has 93 observations, which is convenient because that's the number of counties in the state. And to layer these things in, I just merely have to combine them together in ggplot. So I start up a ggplot canvas. Here's the thing to remember about layers, though. They are rendered in order of you putting them in here. So the first one that gets put in is put on the bottom, and then the next one gets layered on top of that, which gets on top of that, which gets on top of that. So you got to think through exactly what it is you've got. If I were to layer my counties data on top of my hospitals data, those counties are going to cover it. So I want to start with data equals any counties, and then I can just add another one in here. Geom SF data equals any hospitals. We're doing any open hospitals, and boom, we have a map that shows you where each hospital is in the state. In this case, I'm honestly more interested in where they are not. Where in Nebraska there aren't any. So look here at this row of counties. There's not a hospital anywhere in them. There's hospitals to the north and to the south. There's no hospitals here. This and one here, a couple here. You can see there are counties that don't have hospitals in them in the state, particularly in the rural areas. The other thing is, how big are these hospitals? We're going to explore that more in the next class. What I just want to get done with this one is getting everything installed, getting you used to importing geographic data and displaying it using ggplot. So that should do for today. Check out the book. Book has a little bit more of a detailed walkthrough on this. The assignment will have you do some other layering, and we'll get to geographic queries on the next class. So talk to you then.